In order to understand compounds, I need to expand a little bit upon what makes a molecular compound and an ionic compound, what makes them different. So actually I'm going to kind of take off on what I wrote down here. When we have atoms that are stuck together in a compound, they can either be stuck together because electrons are being shared, or they can be stuck together, those atoms, because electrons were transferred. Now, if there's a situation where all electrons are shared, that gives us actually a molecular compound. If there is at least one situation where a pair of atoms are stuck together and electrons were transferred to create that bond, then we must have an ionic compound. So let's take a look at the slides. Okay, so let me go back here. First off, I hope this makes sense, because you guys probably even told me or would tell me that atoms are look like this, where that's the nucleus. We have the protons and the neutrons in there. We have the electrons out here. That's atom A, this is atom B. So electrons are here, we have the protons and the neutrons. It's all about the electrons doing something if you're going to get these atoms stuck together. So now electrons can be shared, and if electrons are shared, we call that a covalent chemical bond. So if these are stuck together, and what I usually do is I do a solid line to show them stuck together. Okay, that is a covalent chemical bond. Now, if electrons are transferred, what's going to happen, and I'm going to actually revisit this idea about using the periodic table, what group an element is in order to know it's what we call valence electrons coming up. But before I get there, metals, hopefully we're okay that those are what on the left of the jag. Most elements are metals. Metals tend to actually give up an electron or two or three or four, and when they give up an electron, or however many they give up, they will become positively charged by however many they give up. Something that's positively charged is called a cation. Okay. All right. Nonmetals, those are the fewer of them. Those are kind of on the right of the jag. Nonmetals will actually accept an electron or two or three or four, and when they pick up an electron, they will become charged, negatively charged, and they are called an anion. Not an anion, an anion. So let me do an example here. If I was to ask you what's the formula for table salt, you guys would probably go NaCl, table salt. Okay, so let's take a look at that. First off, I said if you have the formula of a compound, NaCl is the formula of table salt. If you find a metal, okay, that is an ionic compound. So just based upon what we talked about before, hopefully you guys would tell me that's an ionic compound. All right, so let's look about how electrons kind of do their thing. Now, sodium is a metal. I told you that metals tend to give up electrons. Specifically, because I can look up the group, it's actually, we'll talk more about this later, but it's in a 1A group. It's got one valence electron. It's going to kick it off. I'll just kind of do this. Kick off one electron. And in doing so, now it's no longer just neutral sodium, but it has actually an extra proton in its nucleus than it has electrons, so it's a +1 charge. Okay, this is a cation. All right. Well, chlorine is a nonmetal. And what I say, nonmetals tend to accept electrons. And actually, chlorine's going to do that. So here we go. Chlorine takes in that one electron, and it becomes, since it has now an extra electron, it has a -1 charge. This is what we call an anion. Then it's kind of like, the deal here is now we have two ions that are oppositely charged, and now they can form a ... So my convention usually is to use ... for my ionic bond. So that what I've shown there is an ionic bond. Ionic chemical bond. Cool, that's it. Electron was transferred. Now we have a cation, anion, and now they have kind of a propensity for each other. All right, what else we got here? Okay. So now something I need to talk to you about, whether an electron is going to jump ship like we saw sodium, or whether, like chlorine, nonmetals are going to take in electrons. We can gauge whether that's going to happen or not due to a characteristic of the element called its electronegativity. So electronegativity, okay, the symbol, we use a lot of symbols in physical science. It looks like a fancy X. And actually, it is the Greek letter chi. That's electronegativity. So the electronegativity of an element tells actually kind of what's going to happen with the electrons. The higher the electronegativity, high chi we say, because that X is the letter chi, it means it will hoard electrons. Okay, a low electronegativity means that it will give off electrons. So, are we okay with this now? If I was to ask you which is which one gives off electrons, what did we do? We saw that metals tend to give up electrons. So we're going to see that metals tend to have a low chi, low electronegativity. In a tug of war, in other words, they're like, go for it. They give it up. In a tug of war, nonmetals have a high electronegativity. They have a high chi. Okay, so that is kind of like with the match between chlorine and sodium in our table salt. The chlorine's like, give it to me. The sodium's like, you got it. And they're both happy. So electronegativity, the symbol chi, the Greek letter chi. So, like I said, it's kind of a tug of war between the atoms that are going to be bonded together. So these are electronegativity values, sometimes called Pauling values. Hopefully you can kind of see them. They're a little small. Notice that here we have the Jag. Okay, so the pink are what? The nonmetals. And I told you in a tug of war, they're going to want electrons. And if they want electrons, they are going to form anions. They're going to hoard electrons. Okay. And then the blue ones are the metals. And they have low chi values. They're ready just to give up the ship.